Hello students, welcome you all to the first day of learning named reactions in chemistry. So today we are going to begin with our day 1. Today we are going to learn 5 named reactions and hopefully make a note of all those 5, and as the series get completed all the named reactions will be with you so that you are exam ready, and by memorizing them. Basically, the tool is to practice them daily and memorizing them so that you are well versed with them at the end of the this particular class as well and in the papers as well. So the first one we are going to start is with unit alcohol phenol ether, and there's a first and the basic one is hydration of alkene. So we are going to see two named reactions. One is hydration of alkene and another is hydroboration oxidation reaction. Now what is the difference in this two? First of all, the reagent is same, that is we have alkene with us, but in this case you can see the product form is propane 2-ol, that is the alcohol, the OH group is present on this particular carbon, which is in turn present with the two carbons. But in this case, when we take the same propene, you are getting propane 1-ol. That means the OH group, the alcoholic group, is present with the carbon, which in turn is present with only one carbon. So this particular CH2OH is known as a primary alcohol, and when the OH is attached to the carbon, which in turn whose two valencies are satisfied with carbon, they are known as secondary carbon. So basically you have 1 degree alcohol, 2 degree alcohol, and you have 3 degree alcohol. So when you have carbon with OH, you know that carbon has 4 valencies. One is this attached to OH. This in turn, if it is attached to a carbon, then it is primary carbon. If supposing you have a carbon and whose two valencies are satisfied with carbon, then it is secondary alcohol. And if you have a carbon whose all the 3 valencies are satisfied with carbon, then you call it a 3 degree alcohol or a tertiary alcohol. So the first one here is hydration of alkene. Here in this case, when it is water is added, that's why we have used the word hydration. In this case, the addition is Markovnikov addition. As you all are aware that in the class 11th, we have studied Markovnikov addition. In this case, what used to happen that when an unsymmetrical reagent, that is H2O. Now when H2O is broken, H2O always breaks down into H positive and OH negative. So there is a negative part and there is a positive part. So this is an unsymmetrical reagent. Is added to an unsymmetrical alkene. Now in this case I am finding that there is a double bond, and this side there is a carbon with 1 hydrogen, this side there is a carbon with 2 hydrogens. So it is an unsymmetrical alkene. The negative part of the reagent goes to that double bonded carbon which has less number of hydrogen. So in this case of water molecule, OH negative will go to that side which have less number of hydrogens. So basically you will be getting this product. This particular rule doesn't follow for ethene, because as we know in the case of ethene, there are 2 carbons, both are having 2 hydrogens. So therefore, nothing goes wrong there. So you always get ethanol in that case. Now the reaction always takes place in dilute H2SO4. Next is hydroboration oxidation reaction. This is alkene to primary alcohols, that is 1 degree alcohol, and this addition is anti-Markovnikov's addition, means whatever we have done here, it is opposite here. In this case, OH of water used to go on this position, that is the double bonded carbon which have less number of hydrogens. Here the OH group of the alcohol will go to the double bonded carbon which have more number of hydrogens. When we know particularly what rule is getting followed, this carbon chain can be any long, but you need to just focus on this double bond, where this double bond is. Is that double bond present in an unsymmetrical one? Is it? Because if it is symmetrical, nothing matter. One side you will send OH, one side you will send H. But here you need to be focused when it is unsymmetrical. Now in this case, we use borohydride in the form of BH3, followed by hydrogen peroxide, and in the basic medium, that is OH negative. The addition will look like this. So basically what happens here is you have CH3 CH double bond CH2. This is a propene. You have BH3. Boron's valency is 3, so you take 3 molecules here and you find that the hydrogens will go here. CH3, CH2, CH2B. This molecule will be 3 times. This will be further, in this case, you'll be having hydrogen peroxide addition. You will be getting the molecule as CH3, CH2, CH2OH. And this borohydride will again generate. This will be 3 molecules. Okay, so this is how the reaction proceeds. This two together we can write in a named reaction. So therefore here we have written it directly. So this is how you can word it: propene to propane 1-ol, and this is propene to propane 2-ol, and this 2 of the reactions are extremely important. Now this was hydration. Hydration means addition of water. What happened when we do dehydration? So the third named reaction is dehydration of alcohol. Now this is an alcohol, ethanol for example. Now in this case, when you add concentrated H2SO4, now concentrated H2SO4 is a dehydrating agent. Dehydrating agent means the one which removes water molecule from a substance. Okay, so this, from this molecule, when we remove a water molecule, ethene is left behind. That means it is also a conversion of alcohols to alkenes. You have to remember in this manner as well. Alkene means double bond containing compound. Alcohol means OH containing compound. This was the conversion of alkene to alcohol in both the case. This is opposite of that. Now here the temperature is very much important. 170 degrees Celsius and 140 degrees Celsius. If it is 170, you will be getting ethene, that is alkenes, as the major product. If it is 140, you will be getting ether as the major product. When it is ether, see to it that you write 2 here in front of it, okay, and 1 water molecule is eliminated out. Now this was the case when it is very much symmetrical. But what will happen supposing you have an unsymmetrical kind of a reagent? For example, you have this butane 2-ol. Now this OH is attached to the second carbon, but I have adjacent 2 carbon, to which one side we have 3 hydrogens and one side we have 2 hydrogens. So what will happen in this case? So same reagent we are adding, 170 degrees Celsius we are using, and I'm finding here that I'm getting 2 products. Now why this happen? Whenever you need to do an elimination reaction, means when you want to remove something from a molecule, you always use Sage-Zeff rule. Whenever you want to add something in a molecule, you use Markovnikov addition or anti-Markovnikov addition. When you want to eliminate something, you will always use Sage-Zeff rule. So what does this Sage-Zeff rule says? In elimination reaction involving unsymmetrical compounds, hydrogen atom goes from carbon adjacent to the functional group. So the carbon which is adjacent to the functional group, which is having less number of hydrogens. So from there the hydrogen is going to eliminate, and not from the one where the more number of hydrogens are. So this is a Sage-Zeff rule. This also we have studied in detail in our class 11th. Okay, so what will happen here, that this is the adjacent carbon which have less number of hydrogen. So hydrogen will go from here and OH will go from here, and you will be getting but2ene as a major compound and but1ene as the minor compound. This was dehydration reaction. So what is the keywords we need to remember here? That we need to use this reagent, concentrated H2SO4. In this, 170 and 140 need to be remembered. If it is 170 degrees Celsius, you will be getting alkenes. If it is 140 degrees Celsius, you will be getting ethers. The O functional group, which is attached to 2 carbons on adjacent side, is called as ether. Now, this is the name. There will be a detailed video of nomenclature also. So you will be just, you can just go through that and you can know how we name the compounds also. Now, in this case, you will find that there is an unsymmetrical alcohol we have taken and how the reaction proceeds with the help of Sage-Zeff rule. The next named reaction is esterification reaction. Now here esters are formed, COOR-. Okay, this compound is known as an ester. This is known as a carboxylic acid. So what basically happen is, you should first know how to present them. If it is R, C double bond O, OH. We know carbon has 4 valencies, so 1 2 3 4. If it is like this, C double bond OH, it is a carboxylic acid. If it is R, C double bond O, OR, it is an ester. Now what is this R? It can be carbon, it can be hydrogen. Okay, it can be a carbon chain, it can be a hydrogen. We know very well that R is a alkyl group. I'll be also starting with a series of organic chemistry from basic to advanced. That is, if you will be following that series properly, you will be well versed with your chemistry class, okay, of +2. So therefore you can follow that as well. Slowly I'll be uploading videos on that particular thing also, so that I start from the basic. If somebody doesn't know what is R here, so that particular person will also know what is R called and how do we use this R group, alkyl group, in all our organic compounds. Now this R cannot be H. This is always a carbon. It can be 1 carbon, it can be 2 carbon, it can be 3 carbons. It is always carbon. So after the second oxygen, if you have a carbon chain carried out, it is called esters. Okay, and this is represented as in a short form like this. This is represented in short form like this. Let's start here. Now for esterification reaction, in this case alcohols or carboxylic acid, because both are used, they are converted to esters, and the observation here is that esters are formed with pleasant fruity smell. No doubt when you do the practicals, it is no more fruity, it is of like a pungent odor or something, but we call it a pleasant fruity smell. Now carboxylic acid is represented like this, alcohol is represented like this. In the presence of Kong H2SO4, that is concentrated H2SO4, dehydration takes place. Water molecule is eliminated. And how the water molecule is eliminated? Always remember one thing, that the OH goes from carboxylic acid and the H goes from alcohol. So this front part is here, RCO. From where this H is getting breakdown, that OR is from behind, OR. So this is ester. So if you want to take an example, we can take CH3COOH plus CH3OH. So what I told you, OH from here and H from here goes out. It is a reversible arrow, concentrated H2SO4. You will be getting CH3CO, this front part. Now start from this side, OCH3. Now how to name it? Always start from second oxygen carbon. From this side, it is methyl. 2 carbons left, it is eth. Between single bond, ene. Since it is an ester, it will be called as OH. So it is methyl ethanoate. Again I speak, the detailed video of nomenclature will be there soon, so you will be well versed with those things in a short time. Now next main reaction, the fifth one, is transesterification. Now transesterification is the opposite of the same. So in this case, what do you get? You have an ester or you have an alcohol. So here you can see RC double bond OOR dash plus R dash OH. This is an alcohol. Now here the single dash, double dash is representing that the carbon can be same or the carbon can be different as well. Reflux it, H positive, that is an acid is there in it. Now in this case, what is happening? This R is getting exchanged. This second oxygen R group, alkyl group, will get exchanged with the alcoholic group R, alkyl group of the alcohol. Example, CH3, C double bond O, OCH3, this is C2H5OH, it is ethanol. So C2H5 comes here and CH3 goes here. So we get this reaction, okay? So these are the 5 name reactions that we have studied today. From tomorrow, we'll be starting from the 6th reaction, that is Groves reaction. So what were the 5 name reactions that we have studied? Hydration, hydroboration oxidation, dehydration, esterification, and transesterification. In this first three reactions, it was a basic conversion of alkene to alcohol or alcohol to alkene. In this case, we have learned how to convert alcohol or carboxylic acid to esters. And in this case, we have studied how alcohol and esters are interchanging their alkyl groups. Okay, so this was all for today. Tomorrow's class will be doing reaction 6 to 10 further. Thank you so much.